Hi there, Mr. Sutton here, bringing you the BC Calculus 516 Extra Practice Number 2 solutions on integration by partial fractions. For this problem, we want the antiderivative of this rational function, so there's no way to simplify this further. We're just going to have to use partial fractions to split this thing up and do our ln antiderivative. So setting up my equation here, I've got this fraction equaling a over x plus b over x plus 1. And next we're going to multiply everything by x times x plus 1. So that's just going to give me 3 on the left side. Over here the x's cancel, leaving me with a times x plus 1. And here the x plus 1's cancel, so I've got b times x. Next I'm going to pick some x values that'll help me isolate a and b. So let's get a first, so I have to get rid of b. I'm going to pick an x value of 0 to make that happen. So that just completely gets rid of b, and I've got 3 minus a, or equals a rather, because you've just got a times 0 plus 1. Now for the b value, to get that, I'm going to plug in an x value of negative 1 to this equation. So then this a value is going away because you've got a times 0, and we end up with 3 equals, this is going to be negative b now, so that means b equals negative 3. Now that I've got my a and b values, I'm going to split this fraction up inside the integral here, so I can rewrite this as 3 over x minus 3 over x plus 1. And now let me take my antiderivatives. So I've got 3 ln of absolute value of x for that first term, and now I'm going to have minus 3 ln absolute value of x plus 1 plus c. Looking at my answer choices, I see that that doesn't match anything. So that means I have to combine these using my log rules. To do that, I can factor a 3 out of the first two terms. And then I've got ln of x minus ln of x plus 1. When I subtract logs, I'm dividing the stuff inside. So this is really just ln absolute value of x over x plus 1. And then still have that plus c in there. So that's going to give us choice D. For this problem, I'm trying to get the antiderivative of this rational expression. Since there's no way to really simplify this, reduce it, or even solve it with substitution, I'm going to go ahead and use partial fractions. And I know this is probably a good move because I've got these unique linear factors down here. So let me split this up. I've got the original fraction equaling a over 2x minus 3 plus b over x plus 2. And now multiplying everything by 2x minus 3x plus 2, that leaves me with just 7x on the left. And on the right, I've got a times x plus 2, because the 2x minus 3 part of this is going to cancel. And then the x plus 2 cancels down here, leaving me with b times 2x minus 3. Now I'm going to pick some x values to help me get my a and b values out of this. So first I'm going to get the a value, so I need to pick an x value that gets rid of this b term. So if I zero out this factor, so if I added 3 and divided by 2, if I plug in an x value of 3 halves, that's going to make this stuff come out to 0. On the left side, I'm going to have 7 times 3 halves, which is 21 halves, which is not ideal, but we'll work with it. Over here, I've got 3 halves plus 2 times a, so that's 7 halves times a. And then, let's see, if I multiply both sides here by 2, I've got 7a equals 21. Dividing by 7, I have a equals 3. Now to get the b value, this is going to be a little easier. I just have to plug in negative 2 for x to get rid of the a term here, because this is going to zero out this parentheses. So on the left, I've got then negative 14. And over here, this is going to be 2 times negative 2 minus 3, so this is negative 7b. Dividing by negative 7, I have b equals 2. Time to split up my fraction inside the integrand now. So now that I know my a value, I can write 3 over 2x minus 3 in there. And my b value is going to let me write 2 over x plus 2, and I'm adding these. Little dx out there. All right. So now we're going to go through and take the antiderivatives. Be careful on this first term here. Since you have an inner function here of 2x minus 3, since the derivative in here isn't just 1 like it is with this x plus 2, you're going to have to divide by this linear tail here. So I'm going to write this as 3 halves ln of 2x minus 3 with absolute value. And then this one's a little bit easier. This is just 2 ln absolute value of x plus 2. All that plus c. And is that one of the answer choices? Well, the only answer choice with 3 halves is choice A, and it has the rest of the stuff we needed, so A it is. On this problem, I'm trying to take the antiderivative of this rational expression. There is no way to simplify this. All we can really do is factor and try to use partial fractions to break this down a little bit. So I can factor the denominator into x plus 2 and x plus 8, things that multiply to 16 and add up to 10. And I'm going to set that equal now. I'm going to make it part of an equation, set it equal to a over x plus 2. I'm trying to split this up using partial fractions now, plus b over x plus 8. Multiplying everything by the combined factor here, x plus 2, x plus 8. On the left, I've just got 6. And over here, x plus 2's cancel, so that's a times x plus 8, plus x plus 8's cancel, so b times x plus 2. Now I'm going to pick some x values to get a and b by themselves. So if I want to get rid of b, I pick an x value of negative 2. That leaves me with 6 equals, this is going to be 6a, a times negative 2 plus 8. That means that a equals 1. Next, I'm going to plug in an x value of negative 8 so I can conveniently get rid of this a. So that's going to be 6 equals, this will be negative 6b, because I've got negative 8 plus 2. So then I get b equals negative 1. Plugging all that in and splitting up my fraction inside the integrand, I've got 1 over x plus 2 minus 1 over x plus 8. So now I can go through and take those antiderivatives. This will be ln absolute value of x plus 2 minus ln absolute value of x plus 8 plus c. And of course, that's none of the answer choices because they expect you to combine these logs in this particular problem. Since I'm subtracting the logs, I can divide the things inside. So this is really ln absolute value of x plus 2 over x plus 8 plus c. So that's going to give me answer choice B. For this problem, I want the antiderivative of 8 over x squared minus 4. Now, there isn't really any other technique you can use on this one other than partial fractions after you factor this out. I mean, I was initially thinking maybe I could turn this into an arctan kind of thing, but that's going to be kind of tricky because we would need addition down here with the x squared, not subtraction. So let's factor this out and split it up. This is going to be 8 over x plus 2x minus 2. And now I'm going to try to split that up with an equation. I'm going to set this equal to a over x plus 2 plus a over or plus b over x minus 2. I should probably have a different letter up there. All right, now I'm going to multiply everything by x plus 2, x minus 2 to get rid of the fractions. So I've got 8 on the left side. On the right side, the x plus 2's cancel, so that's a times x minus 2. And the x minus 2's cancel down here, so that's b times x plus 2. Now I'm going to plug in some convenient values of x to help me isolate a and b. I want to get a first, so I need to get rid of b. So I'm going to plug in a value of x equals negative 2. That zeroes out the b term, and this is going to be 8 equals a times negative 4. So then a is going to equal negative 2 if I divide. Next, I want to get the b value. So I'm going to plug in an x value of 2. So that gets rid of a because I've got a times 0 there. So this is then going to be 8 equals b times 4, or 4b. Dividing by 4, I get b equals 2. Now I'm going to split up my fraction inside the integrand and plug in my a and b values. So I've got negative 2 over x plus 2, plus this will be 2 over x minus 2 dx. And let's do our ln antiderivative rule now. We've got negative 2 ln absolute value of x plus 2 plus 2 ln absolute value of x minus 2 plus c. We're going to have to combine these, though, to get one of the answer choices. So to do that, I'm going to factor a 2 out of these first two terms. And I've essentially got ln of x minus 2 minus ln of x plus 2. So I can move these together by dividing this positive 1 by this negative 1. So I've got a ln absolute value of x minus 2 over x plus 2 inside there. Still have the plus c. So that's going to give me answer choice C. For this problem, I want the definite integral from 4 to 8 of this expression. Now, this isn't one that I can do with any other technique. Substitution won't end up canceling out the x, and I can't really simplify this at all. The best I can try is splitting this up and using some partial fractions. So I can factor this denominator into x plus 1 and x minus 3. And I'm going to set this equal now to a over x plus 1 plus b over x minus 3. Multiplying everything by x plus 1 times x minus 3, that gives me x on the left. On the right, the x plus 1's cancel, so that's a times x minus 3. X minus 3's cancel, so I've got b times x plus 1. Now I'm going to pick some x values that are going to cancel out a or b, depending on which one I want to solve for. I'm going to find a first. So let me pick x equals negative 1, so I can get rid of that b term, because then I've got b times 0. So then I have negative 1 equals a times negative 4, negative 4a. That means a is going to be 1/4 if I divide by negative 4. Now I'm going to find the b value. So I'm going to use an x value of 3 because that's going to zero out the a term. So I'll have 3 equals, and this will be b times 4, so 4b. Dividing, I get b equals 3/4. All right, time to plug these back in. So I'm going to split up this fraction inside the integrand here into 1/4 over x plus 1 plus 3/4 over x minus 3. Time for my antiderivative now. This will be 1/4 ln absolute value of x plus 1 plus 3/4 ln absolute value of x minus 3, evaluated from 4 to 8. So there's a lot of different ways I could go from here. I could try factoring out a 1/4. I could try merging these logs together. At the end of the day, I just decided to plug things in and subtract. So I've got all this stuff with 8 plugged in, minus all this stuff with 4 plugged in. And if this were an AP free response problem, I could actually stop here. But I'm going to go ahead and simplify a little bit more. Just in case you see something like this on multiple choice, it's good to know how to simplify with log rules. So going from left to right, we've got 1/4 ln of 9, 3/4 ln of 5, and then over here, we've got minus 1/4 ln of 5. And finally, this is 3/4 ln of 1, but the ln of 1 is just 0, so this actually zeroes out this whole last term, which is nice. All right, going a little bit further, I've got 1/4 ln of 9, and then you'll notice that these actually are like terms. They're both ln of 5s. So 3/4 minus 1/4 is going to be 2/4 or 1/2 ln of 5. And at this point, you could still go a little bit further. We could pop in these coefficients as exponents, and then if I'm adding logs, I'm actually multiplying the things inside, but I have to pop in stuff first. So there's this first one. If I do the 1/4 power of 9, well, that's really the 4th root of 9. Now, the square root of 9 is 3. To get the 4th root, I have to square root the square root. So that's going to end up being radical 3. And then over here, I've just got the square root of 5. So when the dust settles, then I have the ln of radical 3 times radical 5 inside the ln. And if I really want to go further, I can make this the ln of radical 15.